Well, hello, everybody. Welcome. For those who already joined us, thank you for joining us today in this live presentation where we will be talking about using schema agnostic design pattern on ClickHouse database for product analytics. Now, you might be wondering, who's this guy and where is Robert Hodges? Well, first of all, it is nice to meet you too. And second, Robert is probably and hopefully in his bed in a deep, peaceful slumber right now because I believe it is 1 a.m. past midnight for his time zone. So I am the captain now. My name is Raihan Sunny, and I'm a technical marketing systems engineer at Altinity, and I'll be your host for today's webinar.
Yep.
So
Nice
it
to
is
meet
my pleasure, nice to meet you too, Olga. It is my pleasure to introduce you to our awesome guest of today's webinar, Olga Silyutina. Olga has 5 years of experience with ClickHouse for product analytics, previously leading ad tech products inside large social networks, and currently positioned as the product analytics lead at Sumsub, which is an identity verification platform. Now, I'll let Olga tell you more about herself and Sumsub and dive right into the topic of today's webinar. But before I do, a couple of housekeeping things. This webinar is being recorded, and the recording to the webinar and the slides will go out by email, at least if you registered for the webinar. And if you don't receive the email or you haven't registered for the webinar, you can come yell at us at info@altinity.com. That's info@altinity.com. Secondly, we have plenty of time for questions. Please feel free to use your Zoom interface chat and QA buttons anytime throughout the webinar. If the question is relevant to the slide, we will try to answer right away as we go, and otherwise we'll catch all the questions at the end. Now, without further ado, let's pass over to Olga and let her talk about the topic. Olga, the stage is yours.
Thank you. Thank you for the introduction and for hosting this webinar, also to the Altinity team. So yeah, nice to meet you all. I will today talk about schema agnostic approach, which we try to use at Sumsub, and we'll cover some showcases that we faced with to show an example of how you can apply it. But first, I will start from the beginning, and we will talk about the Sumsub itself and describe what we do. So Sumsub is all-in-one verification platform, which helps user to onboard to different products from fintech to transportation. For example, you could heard about KYC is know your customer process, where you need to provide some documents or selfies or questionnaires to describe why you can have an access to this particular product and be compliant and in some regulated spheres. So now we'll talk more about the topic of today's talk is a schema agnostic approach. So why we could need this approach in ClickHouse and in analytics overall? First of all, it will be important when you have an active phase of the development, when you don't know what to expect tomorrow from your features, when you can't expect how your table structure will look like in the next iteration. Another point where you can have these issues with schema is A/B testing and analytics, where you need to add more and more new metrics in different slices, and you would like to make it easy for all analysts, and we will talk about this as well. Also, there are a lot of different problems considering technical logs where you can't predict sometimes what structure these logs will have. And also we will talk a lot about data lake approach as we have it at Sumsub as well. And data lake here is something about database structure that we have and insert a lot of data from different sources, from machine learning, from front end, from back end, and we store it all in one place so that all machine learning engineers, analysts, and even managers can access this data in one endpoint. So let's talk now more about the structure that we have at Sumsub and our data stack. So basically from backend and front-end logs that we have, we generate different events that go into the ClickHouse data lake through the Kafka batching. And after they are inserted into ClickHouse, we would like to make them suitable for product analytics and to make them easily manipulated by analysts. So to do so, we create aggregates in Airflow. Airflow is a tool, open source tool as well, which helps you to schedule your inserts of aggregates into ClickHouse. And we use it a lot, even on analytics side. As well as materialized views in ClickHouse itself. We create them when we don't have so hard logic that we need to create aggregates. And all those code we store in GitLab, and we have versions we can follow there and share between analysts in the team. And after aggregates and materialized views are done, we can work with them in Superset, is the visualization system, BI system, also open source, which helps you to visualize the data in the form of dashboards and charts to show to the business and managers. Also, we have Data Hub. It's something that we use for documentation of our aggregates and materialized views so that every analyst or new employee could just understand what's going on in our data. And also, if you would like to use something like this, an open source data stack that you see on the screen, I can advise you to attend the next webinar from Altinity, which will be covering all of that. So let's start from the first showcase. For this example, I chose front-end logs. Because I think that front-end logs is something that basically every company has now, and a lot of problems people face when work with front-end events from their users. So I will start from the initial state that we had and the problems that we faced. First of all, we had no any defined logic for events that we could insert in our data lake database. And every engineer who would like to just write new event created their own logic and their own namings and etc. So on the right, you can see the example of like how random it could be overall. It could have different length. It could have different number of objects in the action naming. Also, every action that were inserted could have a lot of metadata that also had different structures. And on the other hand, we have one endpoint table, and all those events are going to this table, and they are like huge amount of data, and analysts should get a lot of context to understand which particular event they need to use now to understand how to answer the business question. So all this led us to the thought that we need to somehow organize the data flow and data inserts in the ClickHouse, but at the same time not to ask developers to do a lot of new work and new developments to make it be possible. So we try to do it on the analytics side. I would say that it's called now like ELT somewhere, like something that is replacing ETL now. So we'll talk about this approach. And we came up with the need of event grammar and documentation of this grammar for all the developers and analysts in our team. And then materialized views in ClickHouse that could organize all this data that we have in our data lake into separate tables for analytics use. So starting with event grammar, we need to understand how you would like to see your events and how it's easier for you to find them into the large data lake and large list of events. We came up with this structure. It can be useful somewhere else, or you can also think of your own. But in our case, it was the subject. First of all, is something or someone who does any actions in your service, in your product. Then it is verb, and it's basically an action that this subject does with some object. And basically object is something that is affected by this verb, this action. And at the end, you get the event grammar that looks like 3 different words connected with some separator, and it will be the same structure for all events in your data lake. Of course, if you have this structure and you have constants for all the subject, verbs, and objects, for example, for subject, it could be user, could be client. For verb, it could be open, clicked, or started, or something like that. For object, it could be button, screen, or something else. And if you have such generic names, you definitely need some more information about what is the button, what is the action, and who doing this. And for all those questions, you can write the JSON is something that not really structured in terms of your ClickHouse schema, but you write it into the separate column, and we will talk about that as well. So how you can give this information to your developers and how you can manage the process of setting up the event grammar itself. In our case, we use Confluence and Java or Java Doc. It's something that generates documentation automatically for Java language. And in Confluence, we write the event grammar from the analytics side. We write what we would like to see in our events and which constants we need to have. And then developers, they can code all those constants into the script and then generate the new doc that will always be with them. And every new engineer will know what is the grammar they can use in our data lake. Other tools and formats which you can use for documentation are also the following, and you can use Doxygen or JSDoc depending on which language you work with and which logs you would like to gather. As well as description formats for your logs, you can use just like JSONs, you can use YAML, you can use, for example, Avro as well. It's more sophisticated format for table description schemas. And for description tools, you can try Swagger. Probably you heard of it in terms of APIs, but you can also use it for generation of documentation for your logs and descriptions. Also, you can use just GitLab, where you will see the versions and all the changes you apply to the event grammar, or just Confluence. I think that it is the nice first step if you're just starting, and it doesn't require a lot of knowledge and skills from your analysts to describe these new patterns just in Confluence. So now let's talk more about the context of the user flow that we have on the front-end side. So as an example, I chose the selfie stage. When you do the verification process, frequently you can be asked to make a selfie just to prove that you're a real person and your life and etc. And for this in KYC, there is a check called selfie or sometimes liveness. What we can have here as an event based on our event grammar that we described previously. So for the subject, he will be a user. Then it could be a verb like started, and then it could be a stage where the user started this stage. To give the additional information about this event, we can store additional metadata into JSON. It could be, for example, stage name, it could be screen name where the event is going, or source where it is collected. And I saw the raised hand, so probably you can add now a question and we will then move to the next slide. or just to ask it at the end of the presentation. I think it will be more convenient then. Then we convert JSON into the white table for our analysts, which could use it easily. And let's talk in more details how we can come up with it. So for the JSON structure of frontend logs, you can use something like that. It could be also applicable to any frontend logs in the web, in the like landings or your products, or like in apps and etc. As an action, you have subject, verb, object, event, and here, for example, we have user clicked button. You just construct your event from the predefined constants that you described in documentation. And for the metadata, you can have like source, it's where your action was provided, like your service, probably it is SDK or probably it's landing, etc. It could be a layer key. For example, it could divide events like front-end or back-end logs, so that just in one line of filter, you can get all the data from the front-end or all the data from the back-end side. Then you can always have a screen name where the action is going. It's very important to create the analytical user flows then and calculate conversion rates. Then you can also have object name, for example, the name of the button or the name of the screen or the name of the stage you're doing. And in our case, for example, it's important to have the information of which stage this event is located. And as we decided that we talk about selfie, I wrote there as an example. When we defined our event grammar for activity or action, and then we define the JSON for the metadata, we can get something like this on the screen. It could be a user ID or something that you have. It could be timestamp, then action or activity or event with particular grammar, and metadata, which is describing what particularly this user did and where. So when we have such data, it's really easy already to understand how to find all the button clicks in your data, or how to see all the screen openings in your data. You do not need to go to the developers and ask them how to find this or another event, and you do not know to make some filters like action in and describe all the events that for example, could it include the names of the buttons? Such case would just destroy this simplicity. And after that, we go to the materialized views. And as you probably already know, materialized views store the data that is triggered by the inserts into the base table or data lake in ClickHouse. And they just helps you to optimize having the same selects over and over. So the select from the previous slide could be just created as a materialized view at the end. So why it could be useful and how it will benefit you if you use materialized view instead of just selects on those data that we created. First of all, it is really easy to access the white table about just one particular feature or one particular part of the product. And every analyst product manager can access this data easily and have documentation, for example, in Data Hub about each column. Also, you'll get real-time analytics in materialized views, and it is something that really helpful when you would like to see all new events coming into your database. Also, you can save time of data engineers because materialized views are easy to create just on analytics side. You don't need to ask for the help of data engineers. It makes your queries readable, and of course, you can quicker answer business questions with separate tables in wide format. Let's also a little bit cover the logic of materialized views. So when you have, for example, table actions, which is data lake, you have inserts of data there. In our case, it's from Kafka. And every time the data is inserted, it is triggered, and then your select query in materialized view works. Then you get the new data, which is aggregated, selected from the insert that just was made to the base actions table. So if we talk about the code, it will look like this. You have table actions with no particular structure. Like this structure could be used for any product, basically. You just have timestamp, you have user ID, you have action with event grammar defined, and you have metadata with lots of different JSONs that you can also describe with your developers, but basically it could be anything. And from this table, you create another table, another schema, which is called, for example, frontend actions, which already has something more defined, something that analysts can use and analysts can predict. And in this case, we have as well timestamp, user, action, then you have source and layer. And by these three columns, it's easier to filter your data and to find the actions you need easily and fast. Then you have screen, object name, and stage name that we discussed previously in JSON format. But now you have this JSON parsed into different columns. And for the engine, you can use any that you would like, but here we use replace image tree just to get rid of duplicates. Yes. And then when you created the schema for materialized view, you can create materialized view itself with the select query, and just simple select query, a couple of words like create materialized view to front-end action schema, and you have data in your new brand new table. However, you can want to have some historical data. For example, you had some logs for a couple of weeks, but you decided to create this materialized view just this week. And in this case, you would like to get the historical data, but if you just insert your materialized view select, it will not work for the historical data. In this case, you can also easily just insert new information with the same select to the same structure, just to filter in the data range that you would like. And it's really easy, as well as you see, to have filters like source and layer to get all the front-end logs being written into front-end actions table. And I think that it's very useful when you have different data sources in your data lake. Let's talk a bit about why don't use aggregates here. And I would say that aggregates takes a lot more knowledge and access requirements for making them in Airflow or Luigi or some other tools. Aggregates are not real time in a sense of like you can't get the data every second. And also, you often depend on data engineers, DevOps, because you need to just make sure that all that you commit could be inserted into the table that you want. And with materialized views, you get the same results, but easily manageable and with less memory used. So what is the impact of the approach that we applied? And I would say that it is measured very subjectively on our cases, but the time spent by analysts on the tasks which required to be familiar with new logs reduced from 4 hours to less than 1 hour, because everyone knows how the event should look like, and it's easier to find it in the large database. Time of query execution, when you select JSON extracts itself over and over, in comparison with selecting from materialized views, is almost 2 times faster. And it's always better to have materialized view, which already stores in cache your data, than writing select query again and again. And of course, Superset dashboards optimization. In Superset, you need to have a lot of graphs, and all these graphs should be united by the one data source, so that you can easily manipulate the one data source and affect all the graphs at the same time. And that's it. And let's move to the showcase second. And for this showcase, I decided to talk about A/B testing platform. And we'll talk more about aggregates and application of Airflow. In this initial step, we have the problems which analysts basically face with. When you have a lot of different experiments going on, you need to analyze each experiment with particular select queries every time. You need to conduct the select query for each metric. And if you have, for example, more than one analyst, they can calculate metrics differently, and they can make some mistakes because of that. Also, you need to prepare dashboards for each experiment just to show the results to the business stakeholders. And all of it, if you have a lot of experiments, takes so much time of analysts that we needed to automate it and make it more automatically. So to do so, we needed to calculate the results of A/B tests automatically using Airflow. We also needed to add some metrics without changing schema of the ClickHouse table, because we needed to add new metrics every time. As well as wanted to just see the history and results of all the experiments we had in one place. So to do so, we can use 2 parts: aggregates in ClickHouse and Airflow and visualization in Superset. So let's dive into it. For the aggregates, we understand like summarized table, which can include different tables, which can have aggregate functions, other conditions. They could be really like large select queries, which are hard to execute every time. So you can place them just in Airflow as an aggregate and make a schedule for that to have this information every day, for example. And then when you got the aggregate, you can just have visualization in the Superset based on this aggregate. And these charts will work very fast, and you will get access to the data easily. How to create an aggregate with experimental metrics and experimental results. Basically, you need to create some, once again, overall schema. In our case, it should always look the same, because we don't need which metrics we would like to add to this table, like the next experiment we have. And you can also use the schema for your own experiments, and it's applicable to a lot of different patterns. First column here could be date, then, for example, user or client, etc. Then you have experiment ID. That's how you can find the experiment you would like to analyze. Then experimental group. In our case, it's test or control, or, for example, you can name it like A, B, C, D groups, and etc. Then you have the column metric names with the list array of the names of the metrics. And then you have metrics values. It's something that corresponds to the metric names, but gives you the integer or float values of your of your metrics that you would like to measure in the experiment. And to create an aggregate using select query, and then insert data into this schema agnostic schema. you can just select data from your database, which can look like this. It can have, for example, date column, user, it could have experiment ID already in group, and then a lot of different events that just appeared from the user which was into the experiment. So we now need to aggregate this data into the schema that doesn't require from us to add new and new columns for each new metric that we would like to have. And for example, you can calculate the basic select query with clicks and views for metrics, but then you realize that you basically need the metric of clicks on the main page on your of your landing as the separate metric. In this case, you would need just to add it to the table if we didn't have such an schema design. But in our case, we can just change the select query. We can change the list metric names at clicks main page after views and calculate it after count if. And then you have the same schema, but with different values in it. Then for Airflow deck, you can use something like this code. It could be more sophisticated if you, for example, have some packages that define your ClickHouse environment and etc. But I just show how it overall could look like. So basically, you import some needed packages for Airflow and ClickHouse driver. You provide all the arguments that you need. You set up this schedule interval. For example, we would like to have all this data every day at 1 a.m. And then you just write the query into the insert data task. This query will look like this. And if you, for example, have a different query, you can just change this code if you would like. And after the aggregation is done and Airflow inserted the data, you will have something like this table for your analysts. So you will have all those columns like data, user, experiment, and experimental group. And then you have arrays with metric names that you would like to see and metric values. You can also make this table in a like melted white format and use array join just to get the metric names as something like group by, and then you can filter in your BI dashboard all the metrics just by the name of the clicks and get all the metrics values that are corresponding to the clicks in particular experiment. Then about the overall platform design that could be then generated using all this information that I already provided. So you can use raw data in ClickHouse. It could be data lake. It could be just some table with experimental data. Then you have daily aggregate, which looks like the aggregate that I talked about last slide. Then you might need to have cumulative aggregate, which has the information from today till the start of the experiment, just to calculate the statistics in Python code. And all of this you can use as the part of your Airflow network and create a task that will calculate 2 aggregates and Python code, which also will create another aggregate with statistical results like p-value, minimal detectable effects, and etc. And all those information and all those data tables you can insert into the Superset or another BI system that you have and create a dashboard with the resulting information about your experiment so that every product manager analyst could access it. For example, the structure of the dashboard could look like this. You can have the description of your A/B tests, dynamics of metrics and statistics. You can have also statistics about group size just to make sure that you split it all your users in a right way. And as well for larger images, you can see like it could be the list of information about your experiment. For example, you can store all of these descriptions into the Google Sheets and also get them into ClickHouse using Airflow as well. Then you can just filter metric clicks and get all the information about clicks in control and test. You can just write new queries over it and calculate uplift, p-value, and MDA in Python code in as well scheduling script. And then just show the dynamic and understand where you can stop your experiment and decide on the results. So this approach helps you to get the historical results of the experiments, get the transparency for metrics calculation. So you have one and only rules for creating these metrics. You can also access unified results for product managers and analysts, and they will have same source of truth. And of course, saving time of analytics team for all this select queries over the information from the experimental results. So that is it. Thank you so much for your attention. And I think that we have even more time for the questions. So I'm ready to answer them.
Yep, awesome. Reminded that if you have any questions, you have to post them on the Q&A section, because attendees will not be able to speak into the microphone, unfortunately. So we'll give it a couple of minutes for anyone to think of any questions and post them in the Q&A before we conclude.
So I can start from the first question, I think. So I will read them out loud and then answer them, I guess. Have you considered use dbt tool to manage your ELT pipelines? Basically, yes, we considered it. The problem is that dbt has, I wouldn't even say that it's a problem, but dbt has a lot of new features that we also can use. But for this particular task, we understood that it's enough to have just open source data tools that we use already, and we don't need to develop anything. We don't need to like apply new technology and trying to adopt it. But I'm really looking forward to use dbt and try it out. I think that it can manage a lot of our questions and a lot of our problems here with ELT. And I think it's really suitable for our case and really looking forward to use it. How do you pull data from Kafka to ClickHouse? Do you use ClickHouse Kafka table engine or other tools? So basically, it's more of a DevOps side, but as I know, we just batch our data in Kafka and insert into the replacing replicated merge tree, and that's, I think, it. Probably we use other tools that are also written by developers from DevOps team. And I don't think that we use Kafka table engine as well, because it's not JDBC or something like that. So we have a lot of in-house code to make those inserts. Did you consider using cloud event specification to encode, describe your events? It seems there are similar concepts, source concepts, subjects, etc. I think that I definitely need to look at cloud events. I searched for a lot of tools which could help me to describe these events, but I think I didn't see cloud events, so I will definitely look at it. So thank you. I think that's nice advice. Since Materialized View do not update when the source been altered, have you ever considered using live view? Basically, we have migrations, and I think that those migrations help us to avoid altering the sources. But I think that we didn't use live view as well because Materialized View just gives all the opportunities we need for product analytics now. And also because we have data lake, which has like very common number of columns, which do not change over time. So we have just like event or action and metadata, and that's it. So we don't have a lot of problems with altering the base table. What's your experience with JSON functions in ClickHouse? How performant it is? Did you find any problems in using them? Also, nice question. I really like JSON functions in ClickHouse. I think they're very, I would say, like flexible, and they have a lot of types in it as well. I think that the only problem could be if you have some raw data with more not so easy to write JSON structures, and sometimes you need to apply a lot of functions to it. So you need, first of all, to make something like JSON extract raw, then you need to understand which key you would like to use, then you extract, for example, JSON extract string, and etc. Also, I use a lot of array map functions just to iterate over the keys in the JSON, and I like this combination of array functions and JSON. So I think it's also very cool that ClickHouse has this opportunity. But for the problems in JSONs, I think the only problem is that if you use it without Materialized View, it is slower, but I would say that you can't wait for this selects. So basically it works fine, but with Materialized Views and aggregates, of course, it works much faster. Great questions.
Yep, great questions, everyone. And thank you for answering, Olga. If you guys have any more questions, please feel free to type them out now, or you can reach out to us anytime at info@altinity.com, or talk to Olga directly if you have any more questions or if you come up with anything else. I see a comment on the chat. Olga, would you like to comment?
Yeah, I think we need to read it because I think it's also very useful information and add on to this presentation. Like Kafka and ClickHouse used with JDBC connector and Schema registry and other format, and live events. And this another comment for the another questions is that live events abandoned from ClickHouse. So not recommended. So thank you very much. That's why I think we didn't use it.
Yep, awesome. All right. I want to thank you everyone for joining, and thank you, Olga, for this amazing presentation, by the way. A gentle reminder that Robert Hodges will be back in our next webinar at Altinity. Another exciting topic coming up where Robert will talk about building a low-cost, high-performance analytic platform with Kubernetes and open source. It's basically learning how to make your own open source version of Snowflake. It is scheduled on July 27th, 10 a.m. PDT. Link will be in the chat. With that said, it has been a pleasure to host today's webinar. And if you missed any part of it or missed some of it, reminder that we will be sending out the recordings along with the slides via email. And the recordings will be also posted on our Altinity YouTube channel. That's pretty much it. Thank you, everyone, for joining again. Thank you, Olga.
Thank you, guys.